So we're going to continue to talk about transformations. So in this video, we'll be talking about our second transformation, the translation. Earlier, we talked about dilations. So just as a reminder, a transformation is an operation that maps an original geometric figure called the pre-image onto a new figure called the image. All right, so the translation is just another type of transformation. So the translation basically slides a figure from one position to another without turning it. So it's just kind of going to move the location of the figure. The x-coordinate is changed by the horizontal translation. So x-coordinate moves the figure either left or right. And so if you're moving left, if the figure's on the x-axis and you're moving it left, then you're going to be subtracting if you're moving left, and you're going to be adding to the x-coordinate if you're moving right. The y-coordinate is changed by a vertical translation. And if it's going up, if you're moving the transformation up, then you're going to be adding to the y-coordinate. If you're moving it down, you're going to be subtracting from the coordinate. All right, so let's look at an example. It says triangle ABC has vertices A, -3, 4, B, 1, 3, and C, -4, 1. Translate the figure 2 units right and 5 units down. Graph both triangles. So just like before, we have a rule or algebraic expression to show what's happening to the original point. So we can use x, y to stand for any point. And then if we want to translate the figure to the right, okay, that's a horizontal translation. And since we're moving right, we're going to be adding to the x-coordinate. So if we're moving it 2 units to the right, then we want to add 2 to x plus 2. All right, then we want to move the figure down 5 units. So since down is a vertical translation, that's going to affect the y-coordinate. And since it's moving down, we're going to be subtracting. So it's going to be y minus 5. All right, so if we start with our pre-image, our original point, then the x-coordinate we need to add 2 to that. So we're going to start with -3 and add 2. And then for y, we need to subtract 5. So we start with 4 and then subtract 5. All right, so -3 plus 2 gives me -1. And 4 minus 5 also gives me -1. So my new image, or A prime, will now be -1, -1. And remember, we use A prime to show the new image. It's just a way to indicate that the figure's been moved. All right, so if I do that for B as well, then I'm going to start with 1 and add 2 to the x-coordinate and subtract 5 from the y-coordinate, which is 3. So 1 plus 2 gives me, this is B prime, gives me 3, and 3 minus 5 is -2. All right, for C, I'm starting with -4. I'm going to add 2 to the x, and I'm going to subtract 5 from y, 1 minus 5. All right, so that gives me C prime. -4 plus 2 is -2. 1 minus 5 is -4. So I'm going to put both of these on the graph. So I'm going to start with the pre-image. So -3, 4, 1, 2, 3, and then 1, 2, 3, 4. This will be A. Go ahead and label all your points. B is 1, 3, so over 1 and up 3 would be right here. And then C would be -4, 1, 1, 2, 3, 4, and then up 1 would be C. All right, so if I connect the points, I can see that that's making the triangle. And a translation is just going to slide that. All right, it's going to slide, in this case, to the right. So I need to move it over, and then I need to move it down. All right, so that's what this next triangle should be. So A prime is -1, 1, -1. So that would be right here. That's my new A. And then B is 3, -2. So over 3 down, -2. And then C is -2, -4. 1, 2, 3, 4 would be right here. Would be C prime. Oh, B prime. All right, so then I can draw lines connecting my points and see that this triangle has just shifted from A, B, C to A prime, B prime, C prime. All right, and then if I want to just double check to make sure that I've done this, B should be over to the right 2. So if I move over 2 and I move down 5, 1, 2, 3, 4, 5, then I get my new B. I can do the same with A. If I move over to the right, two spots. So 1, 2, and then I move it down 5, 1, 2, 3, 4, 5. I end up at A prime. And if I do the same with C, if I move it to the right 2 spaces and then down 5, 1, 2, 3, 4, 5, I get C prime. Okay, so that's a translation. Just moves it, just slides it over. Whereas a dilation, you're getting bigger or smaller. This time the shape hasn't changed. Okay, it's just moved positions. All right, like example 2. Quadrilateral FGHI has vertices F1, -2, G3, -2, H4, 2, and I, 1, 2. Graph the figure and the image of the figure after a translation of 4 units left and 2 units up. All right, so we're going to start by writing our algebraic expression or the rule. This time I'm moving to the left. Okay, so that's a horizontal translation. It's going to move my x-coordinate. And because it's moving left, that's going to be subtraction. So I need to subtract 4 from the x-coordinate. Okay, it's also moving up, which is a horizontal change. X is a horizontal change, so it's moving because it's moving to the left or to the right. So that's affecting x. Y is a vertical change. So this time it's going to be moving up 2 spaces, so that's going to be adding to y. All right, so then if I go ahead and use that rule with the original points, F is 1, -2, G is 3, -2, and H is 4, 2, and I is 1, 2. Okay, so for the x-coordinates, I'm going to be subtracting 4, so 1 minus 4, and for y, I'm going to be adding 2. So I'm going to start with -2 and then just add 2 to that. So that gives me the new point, -3, 0, and this is going to be F prime. All right, for G, I'm starting with 3 and subtracting 4, and then starting with -2 and adding 2. All right, so that gives me the new point, -1, and -2 plus 2 is 0. So -1, 0. Same thing for H. I'm going to start with 4 and subtract 4, and then start with 2 and add 2. That gives me H prime would be 0 and then 4. And then I, starting at 1 and subtracting 4, and then starting at 2 and adding 2. So that would give me I prime, which was -3 and +4, like that. All right, so then if I want to graph both of these, I'm starting with the pre-image. So 1, +1, -2 would be down here. That would be F. And then G would be 3, -2, 1, 2, 3, and then down to -2 would be G. H is 4, 2, so 1, 2, 3, 4, and up 2, that would be H. And then I is 1, 2, so over 1 and up 2 would be I. So that gives me the quadrilateral FGHI. Looks kind of like that. All right, and then if I graph the image after it's been translated, then I'm going to start with -3, 0, so 1, 2, 3, and that would be F prime. -1, 0 would be right here, and that would be G prime. H prime is 0, 4, so 0, and then 1, 2, 3, 4, and then -3, 4. So 1, 2, 3, 1, 2, 3, 4 would be I prime. So again, if I connect these points, okay, the shape of my image hasn't changed. I've gone from this translation to this translation. So basically, I've just slid it over. Kind of think of Tetris, where you slide things around. That's what's happening. I'm not really changing the shape. I'm just moving it. All right, and so since translated figures have the same shape, and they also keep the same size, so this is how they're different than a dilation. Dilation, they may have the same shape, but they don't have the same size. Because these do have both, then these are known as congruent figures. So not just similar, but congruent, because they're the same size. All right, so let's continue this with example 3. A computer image is being translated to create the illusion of movement. Use an algebraic representation to explain the effect of the translation from point A to point B. So here's point A and here's point B. So I want to know what has happened. So point A, if I find the coordinates, I can see that A is starting at 3, 3, but it ends up at B, and B is 2, 1. Okay, so I'm going to write the rule basically that gets me from 3, 3 to 2, 1. So if I'm starting with x, y, Okay, how do I get from 3 to 2? Well, I subtract 1. So I'm going to write that as x minus 1. And then if I change 3 to 1, if I'm starting with 3 is y, and I want to make it 1, I'm subtracting 2. All right, so the rule is x minus y, y minus 2. All right, so if I put 2, 1 on this graph right here, then this is telling me to move to the left because it's subtracting. So did I move to the left? Yes. And then y minus 2 is telling me to move down 2. So if I move left 1 and I move down 2, then I end up with the point, which is where B would be on this graph. Okay, so my rule is correct. Look at example 4. It says the baseball at the right was filmed using stop motion animation, so it appears to be thrown in the air. Use an algebraic representation to explain the effect of the translation from point A to point B. So again, I want to start by finding the coordinates of A and B. So A I can see is at 1, 2, 3, 4. A is negative 4. And then it's down to negative 1. And then that I want to move from A to B. So B would be over, so that would be negative 2 for X. And then it's up 1, 2, 3, 4, up to 4. All right, so to write my representation, I want to start with x, y, and then show what happened to get to the next point. So to go from negative 4 to negative 2, if I'm starting at negative 4 and I want to get to negative 2, right, then that means I'm moving to the right 2 spaces. So that's changing my x horizontally, right? Changing it by adding 2 because I'm going to the right. And then if I want to get up, if I want to go from A to B, then I have to move my point up. So to get from negative 1 to 4, I'm going to be adding to y, right? And you could either figure it out, negative 1 plus what is 4, or you can just look at your graph. So to get from here to here, I've moved it over to the right 2. That's the plus 2. And then now I have to move it up. So 1, 2, 3, 4, 5 would be 5. All right, so x plus 2, y plus 5 is your algebraic representation for the translation from A to B. All right, so that's our second transformation. Translations, remember translations are just sliding the image from one to the other because it doesn't change the size or the shape, and these are known as congruent figures. All right, see you soon.